In Excel, this blank sheet is in front of you. Now see, in the top of the ribbon, you see the option data. In the data, at a very much at the right side, you see the one option that is data analysis. Everyone, this is called data analysis tool. But when you are using this tool at very first time, then it is not visible. Okay, in that case, you need to be install this package in your Excel. So how we can install it? So first of all, you have to go to the home menu of the Excel, that is file. You have to click on the file. You have to click on the file. Then go to the option. In the new box at the left side, second last option is add-ins. Click on add-ins, and at the bottom you will get the Excel add-in. Click on go. You have to choose the first option, that is analysis toolpad. Click on it. OK. So automatically your option will be highlighted. So once this option is highlighted, you can see once you click on it, different tools are available in that. You can do ANOVA for the single factor, two factor, with replication, without replication, correlation, covariance, descriptive statistics, then exponential. Moreover, we can see the correlation, regression, and t-tests. It may be two sample t-test, pair t-test, and also if you are dealing with more than 30 sample, that is j-test. In testing of hypothesis, most of the case in the laboratory experiment, in the basic science research, you have to compare the two variables simultaneously. You have to compare two mean of the variables. Is there significant difference between these two mean is present, or is there significant difference is not present? That means significant or non-significant. This is only for taking consideration of the only two variables. Now see, in that case, while making significant and non-significant, you have to first understand what is meaning of the null hypothesis. When you're talking about the null hypothesis, that indicate the definite statement about your population parameter. Means, let us consider in the example, it is given in front of your screen. Let us consider there are two grading systems. That is, first grade is A and another grade is B. So A and B. If you want to compare this mean of those grades A and B, we have to go for the testing of hypothesis. Let us consider for this two grade A and B, if there is no difference between these two grades, we call it null hypothesis. So null hypothesis, before you are going to start your experiment, you have to formulate your null hypothesis. The null hypothesis, most of the way, that means there is no difference. Everything is equal. All parameter effect is equal. So we can say the grade A and grade B having the same level of their effect, or you can say having no difference between these two grades. Once you formulate your null hypothesis, you have to formulate alternate hypothesis. It is a totally opposite of your null hypothesis. And once your null hypothesis, after making the testing, if it is rejected, we call it significant. The significant meaning there is a difference. Okay, the significant, that means there is a difference. And if your null hypothesis is accepted, that means there is no difference. So we start with the z-test. Generally, z-test, it is used for making the comparison between the means of the two variables when your sample size is more than 30. Okay, so I am giving here one of the example. Let us consider there are two grades A and B, and I have to compare the average effect or average of these two grades are significant or non-significant. So I am clicking on the data analysis. In the data analysis, the window will open. At the base of this data analysis, you are getting the z-test. This z-test, that means two samples for the means. So I am clicking on the z-test. Okay. Now the window will open. It is asking the variable number 1 and variable number 2. So first variable range, I am selecting grade A. For the second variable, again I'm clicking it. I'm selecting the second variable. Okay. Now it is asking the hypothesis mean difference. We have to formulate the null hypothesis. The null hypothesis is indicating that there is a no difference, and that's why I'm making the hypothesis mean difference is 0. That means the variable 1 and variable 2 there is no difference. Again, I'm proceed for the variable 1, what is the variance, and variable 2, what is the variance. If it is known, you have to put the variance of those two variables. If it is not, you can make it 1. You can make it 1. Then next, I'm selected the first row as a label, so I'm clicking on the label. I want my output here only, so I'm clicking on it. Okay. So again, I'm repeating. The window will open. You have to first select a variable range 1, variable number 2, variable number 2. Then we are considering, or we are formulating null hypothesis that there is a no difference between two variables, and that's why we are making it 0. Okay. So variable number 1 and variable 2, you can make it the variance is 1. The label, because I'm selected data from the top to bottom, and where I want the output. And just click on OK, my result is there. Now see, for the first grade, you are getting the mean of the grade A, and you are getting the mean of the grade B. Now this is most important thing while making the interpretation based on the results. Most of the case, what happen, most of the students know how to do the analysis, but once the result is generated, but they don't know how to interpret it. Now see, in this case, we have to most concentrate on this value. We have to most concentrate on this value. I'm highlighting it. Now see, those value that is called P less than or this one. Okay. You have to concentrate on these two values. Z critical test. This is two values. Okay. And those values are indicating 1.9, 1.95996 and 1.64485. Those are the critical values, and this value, it is we are getting this value we are getting with making the calculation. Okay, so this is our calculated value, and those are our tabulated value. This is value for the this value for the two tail test, and this value for the one tail test. It is for the 5% level of the significance. If your calculated value, again I am repeating, if your this calculated value is greater than your tabulated value, then you can say it is a significant. I am making this statement again. If your calculated value is greater than your tabulated value, then or its critical value, then your test is significant. So accordingly, you can do our analysis. Now I am giving another option. The window is asking about variance, so we can calculate the variance for the first variable. So calculate the variance. The variance, it is a formula, is equal to variance. The first one dot P, that indicate for the population, and dot S, it is for the sample. So click on the S. So double click on S. So you have to select the data set for the first one. So we are getting the variance for the first and variance for the second. Now again go for the data analysis. Click on the Z test. So I am write down the variance for the first variable is 28.06, and the variance for the second variable is 6.33. Now I am getting again answer. Now see, your value and result will change. Okay, according to your known variance. Now see, here also you have to concentrate on this value, that is your calculated value or Z value, Z statistic value, and this is your critical value where you have to compare with this value. If your this calculated value is greater than tabulated value, you have to treat this value absolute value, and if it is greater than your critical value, we called it significant. So our result is significant. We proceed for the next test, that is T test. Most of the case, when your sample size is less than 30, you have to go for the t-test. When you are talking about the t-test, that is comparison between the mean of the two variables. Okay, is there significant difference between two variables is present or not? Generally, we are using the t-test when your sample size is less than 30. Let us consider, in that case, let us consider we have the two grades. One grade is C, another grade is D. In the first grade, C, we have the number of observations are 9. In the second grade, we have the number of observations are 50. So we have to compare those two variables simultaneously using the t-test. So I am going for the t-test. Again, there are total three options. The first option is t-test for the paired two sample. We are talking on it later. First, we are talking about the t-test two sample assuming equal variance and t-test for assuming unequal variance. Now, how can know is there variance is equal or unequal? So, before proceed to the t-test, we have to understand is there variance is present or not. So that's why we have to go for the f-test. F-test is basically used for the comparison of the variances between the two variables, and at that case we have to use this formula for calculation of it. In the calculation of f-test, we have to calculate s1 square divided by s2 square. S1 that is indicate variance of the first variable and the s2 is indicate variance of the second variable. While making this analysis, we have to keep the large variance at the numerator and the smaller variance at the denominator. Okay. So in case of this, let us consider there are two grades again. I am taking the same data set, that is grade C and grade 2. Okay. So I am making it for the data analysis. There are two grades C and D. I am clicking on the data, and the right side I am getting the data analysis. Click on data analysis. In that you are getting f-test for the two sample for the variance. Click on it. It is asking the variable number 1. So I am selecting variable number 1. Second one, the variable number 2. Variable number 2. Sorry. This is variable number 2. Okay. So just we have to select a variable number 1, variable 2. I am selected the labels. Click on the output range. Okay. I am got the result here in same sheet. So I am clicking on it. Okay. So you are getting the results. Now see in the results, you see the mean of these two variables, variance of these two variables, and you are getting the F statistic. Now see this value. Okay. I am talking about this value. Again, note down everyone. If this P or this value P, if this P value is less than 0.05, then your test is significant at 5%. If this P value is less than 0.01, again I am repeating, if this P value is less than 0.01, then it is called significant at 1% level of the significance. So keep in mind, when we are talking about the 5% or 1%, the 5% that means 0.05, less than 0.05, and 1% that means less than 0.01. Here the case we are getting this value is less than 0.05, that indicate your test is significant at 5%. When you are talking about the significant, that means there is a difference. Okay, that means these two variances are not equal. These two variances are not equal. So I am going for the t-test. In the t-test, go to the data. In the data analysis, click on the t-test. But we know making the f-test, there is a variances are not equal. So I am clicking on the variances are not equal. Then again I have to select the variable range. So I am selecting this one. This is my first variable. This is my second variable. Now the window it is asking hypothesize mean difference. So for the null hypothesis, we are consider in between the two grades C and D, there is a no difference, and that's why I'm putting here 0. I'm making it label because these labels are required because we are selected in the data set, and where I want my output, I want my output in the same sheet. So click on OK, you will get the results. Now see, for these two variables, variable C and D, we are getting the mean of these two variables, variance of these two variables. Now t-test, that means calculate t-value. Now you have to concentrate on these two again values. Okay, just I made one statement about, just I made the statement about if your p-value is less than 0.05, that means your test is significant at 5%. If the t-value is less than 0.01, then your test is significant at 1%. Understand? Now see, here is the case, your p-value is very much less, that is 0.000000 something, that is 236. Okay, that indicates it is very much low, or it is near to 0. It is near to 0, and that's why we can say your test is significant. Your test is significant. That means the grade A6, grade C, and grade D, there is a significant difference between these two values. Now, such kind of things were applicable in most of the case in the forestry research. Some of the students from the forestry background, they are conducted their experiment under orchard situation and open condition. They can use this test for the comparison of these two situations under the orchard and open condition. So they can use this test for the comparison of these two variables. Is there any significant difference between these two conditions? It is present or not? So this is called the pair t-test. The pair t-test, this is called the t-test, and for t-test you have to first understand is there variance is present or not. For this variances we have to use f-test. Now we proceed for the pair t-test. Now, before proceed to the pair t-test, you have to understand at what situation we are applying this pair t-test. There is a first situation when you are talking about before and after. Let us consider one of the company, they are making some advertisement campaign. So after advertisement, so comparison how the sale is increases between before advertisement and after the advertisement, they can compare it with help of the pair test. While making the pair test, keep in mind these two variables should be dependent on each other. Let us consider you have the set of the 10 students. If you apply some nutrients or some like a bormita and all that they are applying to the student. So before they are giving the supplement for the student, 10 student for the week, and after week they are making the weight of those students. So before started the experiment, what is the weight of those students, and after giving the supplement, what is the weight of the student? So such situation we can understand, we can analyze with help of this pair test. So first condition is there should be the dependent variable. Second situation, the both variable should have the same size. The both variable should have the same size. Then only we can use the pair test. Okay. So before and after kind of the situation, then both are the dependent, having the same sample size, then we can use the pair test. For this pair test, we will go for again data analysis. Window will open. We are getting the first option, that is t-test, pair two sample for the means. Click on it. Again, it is asking variable range 1. Again, it is asking variable range 2. Okay. Again, we are consider there is a no difference between these two pairs. I'm selected the level while selecting the data set, and I want my result in the same shifts. So I'm clicking on OK. Okay, you are getting the results. Again, you have to concentrate on these two values. The value is 5.5 e minus 18. That means your decimal point is shifted to the your left side. So value it becomes 0.00000 up to 18 times and then 55. So this is value again very much low. That means less than 0.05 and less than 0.01. That means the comparison between this C and D, it is a significant difference between these two values. Understand?